Hey, it's Miss Pham. This video is to show you how to set up and get your gene expression project together. So what I've done is I've made a example for you so I can show you what goes on what page and what do I want, how do I want it. Let's start with the cover. Okay, so the cover, I told you guys that you picked a superhero and you are to either put a picture of the superhero or the symbol. So for me, I chose the Autobots symbol to show Optimus Prime. I gave it a title, More Than Meets the Eye. I made sure my name is on it so I know who to return it to after I finish grading. Alright, let's go to the next page. Alright, this is the inside page, right behind the cover. This is page 1. On this page, all I wanted was for you to tell me what the protein was and what the protein, where it's found and what it does. So mine is machinase. All Autobots have a protein called machinase. This protein is found in the exterior part of their body. Machinase forms the hard shell of their body for protection and transformation. So I was telling you that this, quote-unquote protein makes their tough metal exterior. That's all I want on page 1. Now let's go to page 2. 2 is tasks 2, 3, and 4. So you're supposed to give me a amino acid sequence, always starting with methionine and ending with stop. So I've already given you 2 of the amino acids. You're supposed to come up with 5 in the middle. Those 5 can be any of the other amino acids. There are some amino acids that help with certain functions, but I don't want you to worry about that right now. We're focusing on your ability to go from amino acid sequence to mRNA to DNA and reverse DNA, mRNA to amino acid sequence. So once you've picked your other 5 amino acids, I've got methionine, serine, alanine, histine, glutamine, valine, and stop. Then I'm going to use my codon chart and I'm going to code the amino acid sequence into mRNA. Now when you're looking at the chart, you'll notice that methionine only has one option, right? AUG. But serine has quite a few. So you're just to pick one of the many that codes for the amino acid serine or alanine or any of the amino acids that have multiple. You are to pick one and stick with it. It doesn't matter which one you pick. As long as you pick one and you stick with it, and if I go through, I can find it on the codon chart and I can follow it back to the DNA. Okay, now let's go to the next page. Page 3. Page 3, I want a description of mutation. So I want a general definition of mutation. That's up here. Okay. Then I want the two main types and their examples. So point mutation. We just went over this. Point mutation is a mutation affecting only one or few nucleotides. The example is a substitution. Then we get frame shift. Frame shift is a mutation that's caused by adding or deleting a nucleotide in the sequence and then affecting all nucleotides after it. For example, we've got deletion, that's still taking one out, inserting or putting a base in. Notice that these mutations occur in the DNA sequence. It occurs in the DNA sequence when you're transcribing over to your mutation. So the next 3 pages that you have left, you're going to be showing me these mutations. So on page 5, or your page 4, you're going to show me a substitution mess up. So I want you to write your DNA, show your mRNA, show where the mess up occurs. I want you to underline it, circle it, draw an arrow to it, whatever you need to show the change. Now in substitution, a mutation can occur, but it may not change your amino acid sequence, and that's what I wrote at the bottom. because I changed this, there was a mess up between this G and this A, and that caused no mutation. I still have the same amino acid sequence. So at the bottom, I want you to summarize what happened. A mutation occurred in the mRNA sequence, but the mutation did not change the amino acid sequence. Now that's a possibility. The other possibility is that it does change. So here again is the DNA, mRNA, and then here is where the change occurs, and it causes aspartic acid to show up in your amino acid sequence. So then I want you to explain it. The mutation caused AA change. Cross that out. A change in the amino acid sequence. Alanine was changed to aspartic acid. Okay, that's the mechanics of it. That's what happened. Now you're going to get a little creative with this part. When it mutates like that, I want you to tell me if it changes to another protein, what kind of protein would it be? So I said the change in the sequence changed the protein machinase to redase, a protein that gives off a pigment that makes the autobot red and does not make their exterior body hard. So I'm saying that they're now a red kind of fleshy color. So I want you to be creative and turn this mutation into a weakness instead of a superpower because of the change. Alright, so these are the two options. I'm going to go back, or I can't really go back on here. On the page before it, you can do a substitution with no amino acid change or a substitution with an amino acid change. Right now you have deletion. Deletion, you're taking a base out. So I just took one out from here, and then everything subsequently pushed over. So this G came over here, and then everything shifted after it. So because it shifted, you notice that it changes. It didn't change the third sequence where this codon was. That's still alanine, but everything after changed. You see isoleucine, threonine, tyrosine, and 2 codons doesn't code for anything. So your tRNA trying to bring and match up is very confused. Nothing's going to be there. So it's almost as if it's incomplete. So that's what I wrote for my description. The deletion mutation caused the amino acid to change and be incomplete. So sometimes that mutation doesn't allow a protein to finish and completely be a structure. Okay, last one, I added a base. So I pointed to where I added one, and then everything after has shifted, leaving me with an extra letter at the end, an extra A. So then if you look at my amino acid sequence I've circled, there's now an extra serine, a proline, serine, arginine, and methionine again. Then I had my description, the addition of a nitrogen base changed the protein and is now incomplete and does not create machinase. The Autobot does not have a exterior hard shell. So again, you start with your cover page, you have your symbol. The inside cover should be a description of the protein and how it helps or is responsible for the superpower. Then page 2 is the normal, the original sequences, the original protein name, the original amino acid sequence, the original mRNA sequence, and the original DNA sequence. Then page 3 is a kind of definition page, the different types of mutations, point versus frame shift, and then point with substitution, then frame shift with deletion and insertion. Then an example of each, an example of substitution being with or without a change in the amino acid. I don't want you to make 2 substitution pages, just to be clear. You're going to run out of space. You only have 1. I just want to let you know that when you're doing this, sometimes substitution does not cause a change in the amino acid sequence. Sometimes it does. You have to be aware of those 2 facts. Then page 5 is a deletion. Page 6 is an insertion. Once you finish that, you can turn it in to me. The latest you can turn it in will be Tuesday, February 16th. If you have any questions, feel free to email me, and